Next up, we are going to be figuring out the amplitude, period, phase shift, and frequency of f of x equals sine of pi minus x. This is a more simple example than we did for example 1. Let's go ahead and get right to it. Step 1 is to convert to standard form. So we want to have it of the form a times sine of bx plus c plus d. So first of all, we want to put a 1 in front of the sign to represent a. Next, we want to flip the pi and the negative x, and then put a 1 in front of x to make it negative 1x. The x should always come first, and it should always have a b value. Then we can see that c is pi, b is negative 1, a is 1, and d is 0. I'm really not sure what I was doing with that slide, but anyways, it's the same thing. Now for step 2, we're going to determine a, b, c, and d. So basically we're just writing that out again. Let's move this. So we have a is equal to 1, b is equal to negative 1, c is equal to pi, and d is equal to 0. Again, I told you that the frequency has to do with the b value. It's actually the absolute value of b, now that I think about it. In the last video I said it was b, but it's the number of times it repeats itself over a distance of 2 pi. So it's got to be positive, right? Okay, next we have amplitude, absolute value of a, so we know the amplitude of this function is going to be 1. Next we have period. Period is absolute value of 2 pi over b. Since b is negative 1, we get 2 pi over negative 1, but the absolute value of that is just 2 pi. So this goes hand in hand with frequency, because if the period is 2 pi, that means it takes 2 pi units to repeat itself. Well, if frequency is how many cycles you have over a distance of 2 pi, it makes sense that in this case the frequency would be the absolute value of negative 1, which is 1. So frequency is actually the absolute value of b. I learn something new every day. Okay, next is phase shift. Phase shift is negative c over b. Again, you can just set what's in the parentheses equal to 0. So c value is positive pi. So be careful about that. So it's going to be negative pi over negative 1 for b. We get pi. So the phase shift is pi units to the right, considering that pi is positive. All that said, let's look at the graph. Here's our function for sine. Now it doesn't look like it shifted pi units to the right because it starts looking like a sine graph, but remember we did other things to the function. We actually had a horizontal flip, which we'll learn about later when we go into more detail with transformations, but this negative number in front of the x will flip it. So that's why it looks like it hasn't moved at all, but indeed there was a phase shift of pi units to the right, as well as a horizontal flip. This verifies that the amplitude is 1. We can see that the period is 2 pi. It takes 2 pi in between these two pink dots to repeat itself. I guess this right here I was representing the phase shift. Pi units to the right. So this is technically the original point of the graph that's been changed around. Like I said, it was flipped as well, so that's why it's going backwards. And then finally, frequency. It does indeed go 1 full cycle over a period of 2 pi, over a distance of 2 pi. So that's it, folks. It's very simple. That's all of the trig attributes that we're going to talk about for now. If you have any other questions about this, let me know.